Children, yes, now it's our exercise time. So let us do the exercise in the workbook of lesson 23, solid, liquids and gas. Okay, yes, so we completed the lesson. So hope you read the lesson nicely. Yes, now we will do the exercise part. So the first exercise in the workbook is exercise 1. Tick the correct answer. You have to tick the correct answer. 1, 2, 3, 4. Four questions are there. Each questions have 3 options. Option A, option B, option C. Read the question, check the correct option. Which option is correct? There you can give a square, a tick mark in the square box. Okay? Yes. So coming to the first one. Matter is made up of tiny particles called dash. Means matter is made up of tiny particles, isn't it? They are called option A molecules, option B solids, option C gases. So all things, whether it is living things or non-living things, they are made up of matter. Matter is anything that has mass and occupies space, and it consists of, matter is made up of small tiny particles or small particles, tiny particles called, yes, molecules. M-O-L-E-C-U-L-E-S, molecules. Option A is the correct answer. So here you can give a tick mark. Okay. Now coming to the second question. A matter that has a definite volume but no definite shape. Yes. A matter that has a definite volume but no definite shape. Which is that? Solid, liquid or gas? Option A solid, option B liquid, option C gas. Solids, the molecules are tightly packed, closely packed, so the force of attraction is so strong, so they have a definite shape and volume. Liquid, they are less closely packed, so they move, they can move. Not the force of attraction is not strong as solid, so they can move, so they flow. Yes, that's why they have a definite shape but they don't have a definite volume. Yes, they take the shape of the vessel, isn't it? Gas, loosely packed, they move freely, no definite shape and no definite volume. Yes, so the matter that has a definite volume but no shape, definite shape, it is option B, liquid. L-I-Q-U-I-D, liquid. You can tick mark here in the square box. So, yes, so the matter that has a definite volume but no definite shape. Yes, liquids, yes, the force of attraction is not strong as solid, because the molecules are less closely packed. So they flow, they can move, isn't it? Yes, so they does not have any definite shape, they take the shape of the vessel, but they have definite volume. Yes, so the correct option is option B, liquid. L-I-Q-I-D, liquid. Liquid has a definite volume but no definite shape. Yes. Now coming to the third question, question number 3. Rusting of iron is an example of option A physical change, option B chemical change, option C biological change. Yes, rusting of iron. In rusting of iron gets rust, isn't it? After the rusting we cannot get back the iron. It does not form iron again. So the substance got changed, nature of the molecules got changed, nature of the substance got changed, and new substance formed. So it is an example of, yes, it is an example of a chemical change. So option B is the answer, chemical change. Now coming to the last question, molecules can be seen only under A. Option A stethoscope, option B electron microscope, option C telescope. Molecules are small particles we cannot see with our naked eyes. We have to see it through We can see molecules only through a, yes, electron microscope. ELECTRON, electron microscope. MICROSCOPE, microscope. So molecules can be seen only under a electron microscope. Option B is the correct answer. So here you can give a tick mark. Okay. Yes children, so our next exercise in the workbook is exercise 2, fill in the blanks. Yes, there are 5 fill in the blanks. Read the questions carefully and write the correct answer. Okay, first one, anything that has mass and occupies space is called dash. Yes, anything that has mass and occupies space is called a, yes, it's called matter. Yes, MATTER, matter. Anything that has space, that has mass and occupies space is called matter. MATTER, matter. Second, water changing into ice is an example of dash change. Water is changing into ice. Yes. Nature of molecules are same. Then nature of molecules are same here. No new substance is formed here, isn't it? So it is a, yes, it is a physical change. Water changing into ice is an example of physical change. PHYSICAL, physical change. Now third one, the substance we get when a solute is dissolved in a solvent is called a dash. When a solute is dissolved in a solvent, we get, yes, sugar in water. We get sweet water. That is a solution. Yes, solution. The substance we get when a solute is dissolved in solvent. Solute and solvent mix together to form a solution. SOLUTION, solution. Now, fourth one, plants and animals in water breathe the dash dissolved in water. Plants and animals that lives in the water, they need what to live? They need to breathe, isn't it? So they breathe the, which gas? Yes, oxygen in the water. Oxygen dissolved in water. So breathe the oxygen. OXYGEN, oxygen. Now the last one, a change in which no new substance is formed is called a dash change. Which change it is? A change in which no new substance is formed is called a physical change. PHYSIAL, physical change. CHANGE, physical change. Okay. Yes, so fill in the blanks. First one, anything that has mass and occupies space is called matter. MATTER, matter. Second, water changing into ice is an example of physical change. PHYSICAL, physical change. Third one, the substance we get when a solute is dissolved in a solvent is called a solution. SOLUTION, solution. Fourth one, plants and animals in water breathe the oxygen dissolved in it. OXYGEN, oxygen dissolved in water. And the last one, fifth question, a change in which no new substance is formed. A change in which no new substance is formed is called a physical change. PHYSICAL physical change. Yes children, so our next exercise in the workbook is exercise 3. Answer the following questions. Yes. So here some questions are given. You have to read the question and answer it. Okay, let us see the first question. See which is the first question here. Yes, why do liquids flow? So why do liquids flow? In liquids, the molecules are less closely packed, isn't it? Not as tightly packed as solid. Yes, they are less closely packed, and the force of attraction between the molecule is not that strong. Therefore, they flow, liquids flow. They can move freely. Yes. So, why do liquids flow? Answer. The molecules in liquids are less closely packed, and do not have a strong force of attraction among them, comma. Therefore, liquids can flow. Because they don't have such strong force of attraction, they flow. Yes. Second, name two gases that dissolve in water. Which are the two gases that dissolve in water? We already learned dissolution of gases in liquids, isn't it? Yes, plants, animals living in water, they breathe oxygen which is dissolved in water, so oxygen. Then when we open the soda bottle or cold drink bottle, gas comes out rapidly, it escapes into the air. It is carbon dioxide, isn't it? Yes. So, the two gases are oxygen and carbon dioxide. Oxygen, oxygen, O-X-Y-G-E-N, oxygen, and carbon dioxide, C-A-R-B-O-N-D-I-O-X-I-D-E, carbon dioxide. So, the two gases that dissolve in water are oxygen and carbon dioxide. Now, the third question, differentiate between solid, liquid and gases. So, you have to write the difference between solid, liquid and gas. So, page number 115 in your course book, there is a table given there. There is a table given. There you can see the difference between solid, liquid and gas. It is clearly mentioned over there. Just copy that here. Okay. Solid, you know, the molecules are tightly packed or closely packed, and because of that they have strong force of attraction, isn't it? So, we can say that solids have definite shape and volume, but liquids, yes, they can move, they can flow because of molecules are less closely packed, isn't it? Yes. So, they does not have a definite shape, but they have definite volume. Gas does not have definite shape and no volume. Yes. And other difference, what you can write is example you can write for solid, liquid and gas as water, ice, water vapor. Ice, water, water vapor. Solid is ice, liquid is water, and gas is water vapor. Or some other examples also you can write, like chair, table and all you can write for solid. Liquid you can write as juice, soup and all. And for gas you can write oxygen, carbon dioxide. Okay. Then first difference is solids have definite shape and volume. Liquid does not have definite shape but it has definite volume. Then gas does not have definite shape and volume. Then the second difference, the other one you can write solids are generally hard, liquids are not hard, gases are also not hard. Then about gases you can write the solid again you can write it does not flow. Liquids it flow. Gas also it flows. Yes. So these are the main differences between solid, liquid and gas. So you can see in your course book page number 115 the differences between solid, liquid, gas are mentioned there. Page 115 in your course book you can see here. Okay. The table you can see here. So see the table and copy it in your workbook. Okay. Yes. So the first one, why do liquids flow? The molecules in liquids are less closely packed and do not have a strong force of attraction among them. Therefore, liquids can flow. Second, name two gases that dissolve in water, oxygen and carbon dioxide. Third question, differentiate between solid, liquid and gas. That you can write from the page number 115 in your course book. Okay. Children, so the next question in the workbook is question number 4. what is mean by a solution? So what is a solution? When solute and solvent mix, we get a solution, isn't it? Yes, example, sugar in water, salt in water, etc. Yes, so answer, the substance we get, answer, the substance we get when a solute is dissolved in a solvent is called a solution. So the substance we get when a solute, sugar, is dissolved in a solvent, water, is called a solution. Yes. Next, define solute and solvent. Now what is solute and solvent? Solute is a substance or the solid that dissolves in the liquid or in a liquid. Yes, the solid that dissolves in liquid is solute. Sugar dissolves, isn't it? Sugar is a solute. Salt dissolves in liquids, dissolves in water. So salt is a solute. The liquid in which the substance dissolves, that liquid, it is solvent. That is water. Yes. So define solute and solvent. The solid that dissolves in a liquid is called a solute, and the liquid in which a substance dissolves is called a solvent. Yes, that is solute and solvent. Yes, sugar, salt is they are solute, water is solvent, and solution we get is, that is solution itself. Okay. Now next is, what is the difference between a physical and a chemical change? You have to write the difference between physical and a chemical change. Give 3 examples of each. So you have to write the difference between physical change and chemical change. Then you have to write 3 examples for physical change and 3 examples of chemical change also. So what is a physical change? A change in which, yes, nature of the molecules of the substance remains the same, isn't it? Yes, no new substances is formed is actually a physical change. Example, yes, when we break a pencil into 2 parts, its size and shape changes, but pencil remains as pencil itself. So nature of molecules is same and no new substance is formed there. So it is an example of physical change. Melting of ice into water is a physical change. Melting of a butter, it is a physical change. These are all examples of a physical change. Now what is a chemical change? Yes, a change in which new substances are formed and nature of the molecules of substance get changes. Rusting of iron is an example. Burning of wood, when we burn the wood, it forms ashes and smoke, isn't it? That again we cannot convert it into wood. Yes, so burning of wood is an example of chemical change. Rusting of iron is an example of chemical change. Baking a cake is an example of chemical change. Here all we are getting a new substance. A new substance is forming. Means nature of the molecules is changing. So that is a chemical change. Yes, so let us see the answer. The answer is a change in which the nature of molecules of the substance does not change and no new substance is formed is called a physical change. So example, you can refer the textbook in your course book, page number 116. There are examples given in the column. That examples you can write. Melting of ice, melting of butter, then breaking of pencil, like that you can write. Now chemical change, a change in which the nature of the molecules of the substance changes and new substances are formed is called a chemical change. Yes, nature of the molecules of substance change and new substances are formed. Example, you can refer page number 116 in your course book. There in the column it is given the example of both physical change and chemical change. You can refer your course book and write. Here in chemical change example you can write as I said you now. Burning of wood, baking of cake, rusting of iron. These are the 3 examples. Okay children? Yes. So What is meant by a solution? The substance we get when a solute is dissolved in a solvent is called a solution. Define solute and solvent. The solid that dissolves in a liquid is called a solute. The liquid in which a substance dissolves is called a solvent. Now the last question, what is the difference between a physical and a chemical change? Give 3 examples of each. A change in which the nature of molecules of the substance does not change and no new substance is formed is called a physical change. Examples, you can refer your course book, page number 116 in your course book. You can write here melting of butter, melting of ice, breaking of pencil. Then a change in which nature of molecules of the substance changes and new substances are formed is called a chemical change. Example, page number 116 in your course book, it is given burning of wood, baking of cake, rusting of iron, all are examples of chemical change. Okay? Next is HOTS exercise. Okay, there you have to think about the question before answering. Yes, let's see what is the question here. Why is it harmful to consume soft drinks on a regular basis? Yes, on a regular basis, continuously, daily, it is not good to take soft drinks. Why? Yes, drinking high amounts of soft drinks on a regular basis means daily if we drink soft drinks or cold drinks, it can increase the chances of tooth decay. Yes, our tooth get damaged if we are drinking daily the soft drinks or cold drinks. Okay, then higher risk of heart disease. Yes, our heart get affected if we drink cool drinks daily. So daily drinking of cool drinks is not good for the health. Cool drinks or soft drinks, they are not good for the health if you drink it daily. Once a while it is okay, but daily on regular basis it is so harmful to your body. You get health problems like heart disease and even your tooth get damaged easily. Then and metabolic disorders, other health problems which affects our body is type 2 diabetes. Your blood sugar becomes high. So it is again a health problem which affects our body. Okay, these are the problems happens if you drink cold drinks or soft drinks on daily basis or on regular, daily, frequently. It is not good for our health. So metabolic disorders means metabolism, our body metabolism get changed, means cells, cells makes up our body. So cells won't function properly. Then we get this kind of diseases. Type 2 diabetes. 2 types of diabetes are the blood sugar, type 1 and type 2. Okay, here blood sugar level becomes high. So drinking high amounts of soft drinks on regular basis can increase the chances of tooth decay, first problem, higher risk of heart disease. Yes, then and metabolic disorders like type 2 diabetes. These problems happens if you drink cold drinks or soft drinks on daily basis. Okay. Yes children, so next is value based question. So each our lesson, whenever we learn a lesson, that lesson has a value, isn't it? Yes, so let us see which value you have learned from this lesson after reading this value based question. So the question is, in solids the molecules have very strong force of attraction among them, isn't it? In solids how the molecules, yes, the molecules they are closely, tightly packed, so force of attraction between them is so strong and are very closely packed. Do you think we all Indians should adopt this quality of staying close as molecules? Do you think like this, how these molecules are closely packed in the solids, same like that molecules, we Indians, we people, Indians, we also should be so close and should be solid with our unity. should be solid with our unity. There should be unity among all the Indians, even if we belong to different caste, different religion, different language, different color, whatever. Even if we are poor, rich, whatever, it doesn't matter. We all should live together, like in unity, in love. So do you think that quality should be there in us, just like in solid, how the molecules are closely packed, and how it is, the force of attraction is strong there. Same like that, we Indians also, we should also be so close to each other. Whatever happens, we should be so close, we should have unity always. Yes or no? Yes. We all Indians should adopt this quality of staying close as molecules and should be solid with our unity. In the case of unity, we should be strong and we should stay close each other. We should not fight. There should not be any conflicts between people regarding the matter of religion or the tradition or the customs or the language, the color or money, whatever. There should not be any clash between them. There should not be any fighting between them. We should stay close each other. There should be unity among all the Indians. That is the value we learned from this lesson. We should all stay in unity. We should stay close each other and our unity should be strong. Yes. Now, home assignment project. Let us see what is there in the project. Make a sugar solution with the help of an adult. Heat the solution till the water evaporates completely. Make a sugar solution. Sugar solution means you have to take sugar, you have to take water, dissolve sugar. Put sugar in water, it dissolves, and you have to keep it in a stove or gas, wherever, and you have to boil it. Heat the solution till the water evaporates. Till the water evaporates completely. The water content should lose completely. Till that you should heat it. What is left behind now? You have to observe what is that. Taste the crystals. What do they taste like? So after heating the sugar solution, when all its water content lose, it begins to turn into dark color. Some dark color thing we can see in that. Sugar crystals. It's called caramel actually. Yes, it turns to dark color, brown color. You have to taste it and you have to tell what taste it is. Actually, for making some candies and sweets on cake and all, this is the recipe. First we do this actually. So just heat the sugar solution and till water gets completed, and just see the taste, or just taste it and see what taste you feel. Okay, so we completed the exercise in the workbook. So now go through each exercise well after reading the lesson, and be well prepared for the exams. Okay children.